Good morning, Paulo. Good morning, Desiree.
Good morning, sir.
Morning, Paulo.
Good morning. How are you?
Good morning, Tierra. Good morning, Ron.
Good morning.
Hello, Ron.
Good day. How are you guys?
All okay.
Fine.
Let's make sure everybody's admitted on here.
I just think it's disadvantage with you guys. I'm having a bit of trouble here with this COVID-9 stuff. Right? I need a haircut.
Oh, Calvin, my friend. How are you?
Ron, morning, Alex.
Hey, morning. Hey, Ron. Do what I did. I just went to Walmart and bought a clipper and I cut my hair myself.
There you go.
I just had my daughter's touch up part of it. I just went bald.
I think that's a good start. Maybe I'll try that.
Yes, it's cheap.
I always cut my hair by myself.
Okay. But that means you have some good skills that some of us don't have. But it's not always easy. But if I cut my hair bald, then I have to wait like a week before I can really come out. Then it's not really, looking proper for like a week. So I'm still going through everybody's morning. I'm still going through everybody's paper. I had a very rough night. I had some serious neck pain, and I could barely sleep last night. Some of you would have noticed I was communicating with some people at 10 o'clock at night.
Too much jollof rice?
We'll be fine.
Oh, too much Nigerian jollof rice, yes. Oh, Turu, how you doing?
Sir, what's up?
Brenda now.
Very fine, sir.
Val. Valentine. I know you. How you doing? Afternoon. So let's see more people in the waiting room. So, Paulo, I hear all the Portuguese being spoken in your background.
I'm going to boot myself because my kids are watching the classes for them. So
for their class, I know.
I will mute myself and I will always only open when I will talk. Okay.
Yeah, okay.
But if you want some gym classes in Portuguese, you are
Did
okay. Yeah, no, my kids, yes, they are doing, yeah.
Well, we do. So we'll see. So I send the message. Hello, Helen. Helen Kim, how are you? And then, so maybe I should also use the opportunity to take our attendance because I was going through the attendance yesterday and it was kind of like tough to reconcile everybody. I'm almost having to watch the videos, but we're almost done. One more day left.
Hi, doctor. Sorry.
No problem.
Heading to my son.
That's all right.
I had the microphone on mute.
This is called the new normal.
Yeah.
Yeah.
The new normal.
Yes,
so it's 10 o'clock. So let's start because of this section we're going to be covering today. Let me go quickly into respect everybody's time. Make sure that we are recording so that we don't have that those who couldn't attend could be here. And okay, good. My time is running up there. All right, so I have a networking background behind me. Desiree, you just changed your stuff to U.S. Senate, right? Anybody that's just coming, make sure everybody's on. I need to let anybody in. All right. Let's share the screen. Can everybody see my screen?
Yes.
All right, let's admit somebody else that's coming on board now.
Yes, we can see the screen.
All right. We're going to give them, I'm going to start, but I give them 4 more minutes. All right, so today we're going to look at networking concepts. And as I said, this is something that a lot of people have a problem grasping. Even initially for me years ago, I had to take several networking classes before taking the Net Plus exam. And then, of course, I went subsequently to get the Cisco CCENT certification. All right, so here I just want to talk about the components and the functions of computer networks and then discuss protocols. And then how to connect a computer to wired or wireless network. I believe that networking is the foundation of most IT work. In fact, all IT work, even if you're just going to do cloud computing, you need to understand networking. Okay, everybody's on. You need to understand networking. So in general, I want to make sure everybody understands the distinction between clients and a server. So usually we have peer-to-peer, which is one computer to another computer, and everybody shares their resources and is in control of their resources. Meaning that if I want you to look at my file, I give you permission to my file. If you want me to look at your file on your computer, you give me permissions to look at your file. That's called a peer-to-peer networking. But obviously the issue with that is, suppose I've got 20 computers. That means all the 20 users have to individually be giving me rights to themselves. That's the advantage to client-server situation, which means I have maybe one computer that is sharing resources to many other computers. So now we have the terminology local area network and then wide area network. So LAN really is more like everybody's on the same, we might use the word subnet. So it might be like at home, all the computers in your home will be on a local area network, or if you have a small office or just general office, those are in your LAN, local area network. So wide area network is more for between network, like maybe my network at home or your network in your house or your office, we use the word wide area network. So sometimes you hear the word MAN, Metropolitan Area Network, which is really part of a wide area network. All right, so network media, terminology, whenever you hear the word nodes or host, usually that are end, you can hear the word end device. So my computer would be like my node, and to distinguish between the server. And then wired data connections, there's usually 3 ways of having a wired connection. Copper cabling, which would be like the RJ45 that we talked about yesterday. When you look at those coppers, when you look at the cable at home, those cable is your copper. And then fiber optics cabling, some people may not have seen that, but that's the expensive ones that you have, like say for those who are in Nigeria, that goes all the way through the water and comes out by Lagos. Or if you're here with me in Virginia, that comes out by Ashburn, Virginia. And then of course you have the Ethernet, which is what I was mistakenly talking about. That would be the RJ45 cabling. And of course you have the wireless, which is Wi-Fi. And then we have WAN links again on there. You can have point-to-point radio, because you can have it through cellular, and then you have it through satellite. The distinction between, going back to the slide, the distinction is usually I'll use cellular, obviously, if I don't have wired, or if I'm being mobile. I'll use satellite if I'm in an area where I don't have access to a wired network or cable service. Satellite, the main issue with satellite is it's subject to interference by environmental factors, wind, hurricane, ice, those are the limitations. But obviously, it is very portable or versatile, because if I'm somewhere up in the mountain, I have to use satellite. Also, addressing, let me make sure everybody's on here before I lock the class, get back to. All right. Let's wait for everybody here. I've got Yanis.
The Galaxy one is mine, Alex.
Galaxy, so okay, Remy, you're coming from home?
Yeah.
All right, so I think I've got everybody in now. It's 10:05. All right, so I've got everybody in here. All right, so we're locked into the meeting. So go back to my slide. All right, so addressing and protocol. So if I'm going to send something from my house to Remy's place in London, if I'm going to sell a letter to him, I need to know the address. And he and I have to agree on how I'm going to communicate with him. So that would be the protocol. But addressing is, how does he know I'm going to send a letter? I need his address, he needs my address. So similar concept with their computers. So standard protocol, it just says it's a format for the computers to exchange data over the network. So we have the word frames or packets. I'm going to tell you the distinction of those terminology when I get to a little diagram in a minute. Obviously, I also need interfaces. Every time I'm sending something, if you go to atawatech.com and you want to download or communicate with atawatech.com, you have to use some kind of all right, go back to my slide. Some kind of payload and a header, which the header determines certain things, but the payload is really what I'm sending. If I request a web page, that would be the payload. Other things are just for communication purposes. So network standards, it says include Ethernet, which is the cable links, and Wi-Fi, and most local networks. They use TCP/IP and then IP addresses. I believe Remy is one that asked me about IP yesterday. Now we got TCP. So TCP here is transmission control protocol. Right, and I already told you yesterday IP means the internet protocol. All right, so just to distinguish between packet transmission and circuit-based network. Think about a phone line just take a phone line. If I'm talking to you on the phone, I need to send the whole packet at the same time. I need to send the whole communication at the same time. But with a packet-based transmission, I divide it up. So if I'm sending something like a web page, if it's too big, I portion it up and I send it out through different means. But at the end, I have to reassemble it. That's just what packet-based communication means. You chop it up into small portions. Also, that means that if a portion is lost, I can resend that portion. So just know that circuit switch means everything just goes at once, and I have a dedicated switch to send it. With packet, I divide up the information, but I reassemble it in the other line, which means I must have like some kind of numbering system to be able to know what I'm reassembling at the other end. All right, so this is the normal protocol that they tend to put in the A+ exam and this ITF, but I also include the next one because you need to be able to compare. So on, we call this the TCP/IP protocol suite. This is the layers. If I'm sending something, it's just telling you that any communication between one computer and another computer, we have to divide up into layers to explain what is happening. So here you have the link layer, you have the internet, the transport, and application. But I prefer to use the OSI model in explaining this to my students. So if you want to remember this, I use the acronym ATIN, T-I-N, because really the last layer is called network. It just says link/network interface. So A for application, T for transport, I for internet, and then N for network layer. So I think about a TIN or CAN. So I use 18 to remember. But in this TCP/IP layer, if you see on here, usually the lowest layer, which is called layer 1, will be your Ethernet, Wi-Fi, your local network segment, frames, and then internet layer talks about the communication, and then the transport says using UDP or TCP, UDP meaning user data protocol, and then the application layer. But better yet, let's use this one here. This is the Open System Interconnect module. This is what you also will see, I think, in a more advanced form in the A+ class. And a lot of network people prefer to use this one to explain what happens when I'm communicating on a network. So if you need to remember the acronym, we have several acronyms for you to remember. Number one is all programs seem to need data processing. All programs seem to need data processing. The A means application, the P presentation, the S, as it says there, session, transport, network, data link, and physical layer. That's going from layer 1, which is the physical layer, all the way to layer 7, which is the application layer. But people also prefer to communicate in terms of, hold on a minute, guys. Somebody says, well, I'm gonna have to do that. People sometimes prefer to communicate going from the lowest to the highest layer. So we're gonna call it, please do not throw sausage pizza away. So if I'm sitting down at home and I want to use my switch or my hubs or my router, however I want to communicate with you, I'm going to send you bits, binary zeros and one. That is the physical layer. And over there, you see the equipment on there usually. And then, of course, the next one is the data link layer. Data link layer is what we have the switches operating. So over there, what you're sending, the name of the data is called frames. And after that, next I get to the network layer. Now, the network layer, I'm using packets. Transport layer, I'm using segments. And then the application layer, which is the session presentation application, we call it data. So just know those terminology. And also in security, you need to know if I'm buying an appliance, am I doing an application layer firewall or am I doing a physical firewall? So to compare the two, this is a diagram that relates to two. You see in the TCP/IP, the up3 application relates to the upper 3 in the OSI, transport relates network, and then of course the network interface. All right, so but let's talk about the IP. So if I'm going to send something to you, I'm going to have to identify that it's coming from me, which will be my source IP address. And I need to talk about the destination IP address. It'd be like my house address going to your home address. But I also have to say, what is the protocol I'm going to use to send it to you? Usually you see HTTP, HTTPS. Those are like protocols explaining what's going on there. But in this case, it indicates whether the data should be passed to the UDP or TCP at the destination host. Sometimes you have what's called a checksum to make sure that nothing has changed in the transmission, right? So time to leave is TTL. Most people will know about it in terms of how long it takes to communicate, or when I'm doing what's called, if I'm pinging somebody to see do we have communication. Don't worry about that word ping. It just means I'm saying, hey, can I communicate with you? Can we talk? That becomes an advanced networking concept, right? But any IP address, so we got two IP addresses we have to deal with today. So you got the IPv4 and the IPv6. IPv4 version 4 has 32-bit binary that we talked about the last time, and it's noted with dotted decimal. That's what most of you may be familiar with. But IP addresses, because remember, all of those, if you see the first one on there has 172, you can go all the way up to 255. So the IPv4 addresses have been exhausted. So that's why IPv6 addresses came up. And there are 122-bit addresses, and they use hexadecimal. So when we were doing computation 2 days ago, I was telling you that you need to be able to know how to convert from decimal to binary and vice versa, so you can be able to tell about IP. So conversion is significant for what's called segmentation. So if I want to divide up my network into different segments, I must be able to convert the decimal to binary and then divide it up. Again, if you're confused, just understand this. Assuming I'm in an office, I got four floors in my office. Maybe floor number 1 is reception, number 2 might be production, floor number 3 is call it admin, and maybe floor number 4 is the conference room. I will want a situation where I have all of those people, we all on the same company, but I want different network, because maybe I don't want people in the reception area or people in operations to have access to the admin levels or something because of other privacy. That's why I would divide up my network. All right, so network preface. Here I should tell you that, so to get into any network, you need to have, let's change this to, I like to do it as a slideshow. All right, so if I'm trying to communicate with you, everybody sees my screen. I know I muted everybody, but let's unmute and see here, hold on. Everybody can see that screen, right?
Yes, can see the screen.
Yes.
Right.
Yes.
So let me mute everybody back.
Yes, yes.
All right, so an IP address, it says it contains a network ID and a host ID. So the network ID, will be like what everybody in the company is using, and a host ID would maybe identify myself, my own computer, or my own node. So if I'm on a 192.68.100, that's maybe my, and then 0.0, the 0.0, 0.1, 2, 3, 4 down the road represents the host. Another portion will be considered maybe a network ID if you want to think about it as a whole, right? But to get into a network, you have to have not just your network, you need to have your subnet mask. Subnet mask is usually telling somebody's looking at it, will know which portion is a network portion within the IP address. Don't get lost with that. Just know that in the whole address, if I see, as I just showed you, 172, a portion represents the actual computer, the host, and a portion represents the network. You need to know those things later on for what is called classless interdomain routing, CIDR notation. But for now, just have that working knowledge. All right, so if you look at your phone has, your phone is on the network. Your phone will probably have an IP address, or your laptop, if you're using your laptop now. Your laptop will have an IP address to get into the internet. But it also will have a MAC address, which is 48 bits expressed in hexadecimal. So the hexadecimal portion, on that, half of it represents the manufacturer, and the other 24 bits represents that particular device. So if I have a HP laptop, the first 24 would tell me this is a HP, and the other one would tell me my particular own system. So I will know what the original equipment manufacturer's ID is. Right, so it just gives you, there are different ways to notate it, but that's just a simple way to do notation also. But all ARP means, if you hear the word address resolution protocol, is this. If I get on a network and I want to communicate on the network to say, I'm here now and I want to talk to Calvin's computer. So my router wants to talk to the router with Calvin overseas. How does it know my MAC address and my IP address association, right? So app identifies my MAC address with my own IP address. So it resolves that and it builds a table to put it in there. So, okay, this MAC address goes with this IP address. When you take advanced networking class, you hear about what is called the FFF, which just means I don't know which person I'm going to communicate with, so I now flood it for that normal FF to identify, saying, hey, who has this IP address? And then you now respond, and I will now enter it in my table. And of course, you can have what's called a reverse app, which now goes in the right direction. So that's just a routing just forwards a package to the destination. So if I'm communicating with, say, let's say Paulo in Portugal, it doesn't necessarily mean that I'm communicating directly with Paulo. I might have to go from my router here to Xfinity router. Xfinity might have to go to another router in Maryland all the way to the US, and then go to Portugal, and then before it gets to his city, Lisbon, then back at his home. So you go through several intermediate routers. So there's a command that you can enter on your computer that's called traceroute, traceRT for Windows, or traceroute in Linux. It would tell you the number of hops to get to your destination, who you're talking to. All right. So domain name service, DNS. So we already said you have IP and MAC addresses, right? But computers has 192.68.10.0. But what does that mean? You are looking for google.com. So if I want to get to google.com, I type google.com. But computer wants to deal with binary numbers, right? So google.com has an IP address associated with it. So if I was to say I was to come over here and I say CMD, for example, right? And I need to know what is google.com, right? If I wanted to ping, say I was pinging, remember before I said ping, I want to ping google.com. So it's going to people.com. You see that TTL at the end, the time to live. I see an IP address on there for 172.217. Tell me that's Google's IP address. So we take that IP address and convert it to binary for the computer to know. So, but you don't want me to tell you, oh, type 172. Blah, blah, blah. You want me to tell you a URL name. If you go to like, again, at towertech.com, you type it in, it is the DNS, the domain name server, that converts that word into an IP address. I can also, as I said, I use the word traceRT. I said google.com. and then it's going to tell me how long it's taking it to. It's going to give me. If it takes a while, I'm going to kill it. But it's going to telling me, okay, I'm going to google.com. I can also enter the IP address instead of entering the name, right? So I let it go, and it's going to tell me how long it's going to take to reach there. I can kill it, but I think it's almost done. It should be no more than 10 hops to get there. And while that is coming, so if you're looking at it, you say, okay, from my place, look at how many intermediate routers it's going to. It's giving me the addresses, obviously. And it's telling me, okay, I go to 61. It starts at 96.1, 30, and it's going all the way to find my final destination. Right? And then now says complete. So it took about 11 hops. We call that word hops to get to my destination. So, but if I didn't want to go through all that, I can just say ns lookup. Let's see. All right, so that now tells me that that google.com. Hang on a minute, sorry. I'm going to backtrack and type also go reverse. 172.217.5.228. Make sure I'm typing it correctly. Right? So I type that IP address and it tells me that IP address, it tells me, okay, that 172.that, or before it also told me was google.com. So I can do it in reverse and know where I'm going. So you would have seen on here Google, right? But I know that was Google anyway, but for some reason it stopped on here. All right, let's see here. Go back to...
I think that's google.com. You put google/com. Maybe that's the problem.
Oh, I put google/com. Let's see here. Go back to my command. In the command line, you always enter your thank you, Desiree. You just always, all right, so it matches it to that other 172 that I got, right? So let's go back to there we are. All right, just confirming. So we're back to the slide, correct? Everybody seeing my slide?
Yes.
You see the slide? Okay, good. So that's what the DNS does. It converts the actual words, call it that, a real domain, a real website address, URL to the number. All right, so because that's what's easier for you and I to remember. But it wants you to understand what I call top level domain names, which is .com, .edu, That's why people, obviously, those will be more expensive if you're trying to register a name. So TLD, top level domain name, that's what that means right there, right? So going back to, all right, so host name is says allocated host is up to 256 alphanumeric character. So if you hear the word FQDN, it means your host name, domain name, and then your TLD, who's hosting it. That's what the suffix. So that's what FQDN means. All right, so this gives you an example of when I was going to find Google, or they use CompTIA here, I can go to one server. If I cannot find it, it goes to another server, and then eventually now returns for me that IP address or vice versa. So it doesn't mean, most times most people have a DNS obviously built into their home router, especially like an all-in-one, but in a network situation, you might have a separate server, which means a separate device or computer that serves as your DNS server. Sometimes you see people have the same DNS server as the same default gateway. So on the issue about the default gateway, let's see here. I can say I wanted to come back to my command line again, and I had typed. If you cannot see my command line, let me know. Everybody can see my command line? Are you seeing my command line?
Yes.
So on here, I was telling you that I'm looking up the domain, right? So I wanted to find out what my DNS server is. Let's just say ipconfig, and we use the word /all. Please don't worry about this command. I'm just trying to use it to tell you something. So I see on here, it tells me, we talked about the word subnet mask. It gives me an IPv4 address. We're going to talk about DHCP is just a dynamic host control protocol. It just allows me to get IP address automatically from a server, but don't worry about it. I'm looking for your DNS here. So it says, gives me a DNS on here. All right, so back on our slide. All right, so that's a DNS server explanation, and we talked about URL already yesterday. Uniform address locator, right? And you see file path name like here. So it's telling you that number one here, I've got comtia.org, and I've got the actual file in here. That's what's the distinction. The file path, this portion, the host name, which is the IP address, or more typically the FQDN. The protocol, remember in this case is HTTP, which you prefer HTTPS. All right, so this is the back on that TCP IP model. So it's telling you that the transport layer, you know, it does the addressing and the connection. Same thing with the OSI model. And then it says the application layer protocol at user level. So if you want to understand this, you look at this. That's why I said I prefer this other chart in here. You see on here, it tells you that the transport layer does end-to-end connection and reliability. So if I'm thinking about what kind of equipment, like a physical hardware I use, I know that at the physical layer, I'm using what's called a hub. At that data link layer for frames, I'm using what is called a switch. At the network layer, I'm using routers. So it helps me to remember what I'm doing. So I'm doing routing of packets. That's what I just explaining to you there, right? All right, so back to where we were. All right, so now HTTP talks about it. It tells you what HTTP means, right? This is the basis of the World Wide Web, and this is what enables clients to request resources, right? You got a web server, intranet, extranet. Intranet is like a network within a company. Of course, extranet is between other companies. Sometimes extranet could be confusing, but usually within shared corporations. But intranet, we are all inside our own company. Yesterday, we talked about SSL, and I think one of the questions that I gave you means secure socket layer, and then TLS, which is the newer one, transport layer security. So this enables me to have secured communication. And how do I get secured communication? By encryption. And then this is another new term in here. Sites present a digital certificate. It's just to make sure that somebody has said, hey, that site is reliable. That site is trustworthy. And it's done by what's called a certification authority or certificate authority. So when you see it, you can say, okay, that site from Alex, which he got from Google or he got from Amazon, is a secure site, so I can trust the site because I trust the other company that gave him the certificate, right? Here you just need to know is this terminology in here. I want to explain multiple internet mail extension. You hear the word MIME, that's what that means. But the main thing you need to under here is SMTP. If I want to send mail, I must have SMTP, which has a different what's called port number, but don't worry about that for now. And you hear the word mail exchange. But if I want to receive email, I must have POP3 or IMAP. And once upon a time, POP3 tends to retrieve the email from the server to your local system, but IMAP leaves it on the server. So just know, sending, I need what's called SMTP. Receiving, I need POP3 or IMAP. This is just telling you how to configure an email. You can look at this slide in case you want to configure your email or configure an email for a client. All right. So let me talk about connecting the network, and I stop for a little question. So if you want to connect to a network, it's just telling you that you have devices that you need. Since I mentioned some of these devices, I will stop when I get to the end of this for a minute. So SOHO, you hear the word SOHO, which means small office, home office. Most of the time they are combined. You have the router and the router, modem, even the switch all combined together. But know the distinction here. A switch connects 4 or 8 computers together in a LAN using the RJ45 cable. You might hear the word Ethernet most of the time when you're referring to switches. But critical point here is he talks about something called a twisted pair cabling. That cable that goes into your wall and goes into your router, if you really look at it closely, you will see the different color wires. And if you take a little device and strip off the casing, you will see that the wires are twisted. It is twisted to avoid what is called crosstalk. That's the purpose of twisting it. So the tighter you twist it, the better it is, right? And the access point, it says, is for me to create Wi-Fi. So even if I have a router, I must have a Wi-Fi, I have an access point so I can have Wi-Fi. Otherwise, all my devices will have to use that wired connection. Nowadays, you might have a router from your cable company. Desiree is an expert on this part. It will have an all-in-one in there, so you don't have to buy a separate router and a Wi-Fi on an access point for Wi-Fi. We remember a long time ago when Wi-Fi first came, you have to buy, like Linksys was a major supplier, and you now have to connect it to your router so you can have wireless at home. And it says that the router obviously connects the wired and wireless network clients via a WAN link. Terminology that you should be able to understand: DSL, which is digital subscriber line. It's a broadband over copper telephone cabling. So DSL has to do with telephone, right? So you have an interface for your telephone network. Via, we see this one now, RJ11. So DSL, you will see that smaller wire, a smaller cable. We call it RJ11, registered jack 11. It goes into the wall, your telephone line, and it goes into your modem. And then usually you need to probably have a filter so that the data and the voice are not interfering with themselves. And then fiber optics, I already mentioned to you, it's expensive. There are different types of fiber optics cable. It is expensive, requires specialized skill, but it's also the fastest. And of course, you have your cable access in there. So if you're looking at your computer, on the lower right-hand corner, you'll be able to see an icon that tells you whether you're connected. Obviously, the yellow one with the question mark tells you need to pay attention to it. The X is really, really bad. It means you got a major issue, right? So to check if you have a network connection with a client, you just try and see if you can browse the network, and it will tell you. I talked about satellite before, usually more in rural areas. It says high latency. Yesterday we talked about latency, means delay. Cellular radio, you have a word called cell. That's where the word cellular comes from. And again, forget all this recent rumor that 5G is causing coronavirus. It's not true. 5G is going to be a disruptive technology that will change how we do things. Obviously, now most people are using 4G LTE to have both data and voice on the same line. The issue about Wi-Fi, there are frequency network I want to talk about, but you have either open or public access points. Public access points, you have to be careful where you don't have to enter any credentials. Be careful about obviously doing banking transactions. But this is something that if you don't know now, if you're going to do the A+ exam, you need to have this memorized. Just know that the most recent one that they're going to be testing you on is what's called 802.11ac, came out in 2013. That's the current standard for Wi-Fi. So, but most people will also see the 802.11n. The significance, if you see, it has 2.4/5 gigahertz. Part of the problem with that is that most things like cordless phones at home are on 2.4 gigahertz. So you might see interference. That just means you probably need to switch the band. So 802.11n is common because it has those two bands. But you have a lot of devices, the access point. If you go buy one or if you get one that's included, it will tell you, you will see some that combines AN or AGN or just AC and B. But you see them including multiple ones. Typical question, say on the A+ exam would be, you need to decide what is best for your client based on what your client wants to be able to do. right? So it's telling you that an access point can support a mix of different standards. So the current one, it tells you is N and AC. The other ones are legacy, meaning they are old. Oh, let me go back here. So you always want 802.11. Yesterday we said you need WPA2-AES. You don't want WEP. If you remember from one of the exam questions. And obviously we want AES with 256 what's called bit encryption. But if you have to set up your system, you will see it. It will give you the option. And please choose WPA2 with AES 256 as encryption. All right, so if you want to, it says configuring an access point, you must connect to admin interface via your access. Remember yesterday, you just typed this on the internet. Your manufacturer will tell you what you need to type to configure that access point. You log in and we said, please change your admin password and your SSID, that is the name of your wireless access point. Sorry, I'll go back there, right? That's what this means, right? And then because there's already default ones that people can find on the internet. Again, the encryption, I already said that already. You always want to do WPA2. Oh, let me mention WPE, because sometimes people confuse WEP with WEP because it's not on here. So, I mean WPS. So on your router, you will see a button. So if I'm trying to connect to your system, you can just push that button to give me access. But security best practice is to disable that. So the issue about it says this one, pre-shared authentication means passphrase. Everybody that wants to get on your network, you give them a password, you call it. That's all that means there. And then of course, open authentication is for if you disable encryption, like hotspots, just be careful. But if you notice sometimes when you go into, like if you go to McDonald's or some of the stores, they have open access. They will also ask you to authenticate via a captive portal that you just have to push. This is just telling you this is simple. If you've tried, if you ever connected, you will see this on your phone before. It tells you your network location. I have my computer set that if a network is public, it will not allow me to go on the internet. I have to actually manually go and say, okay, allow this network in my system, which is a good practice for you. So you don't just log on to a public network and then start surfing the net, exposing your system. The normal range for Wi-Fi tells you on here is about 100 feet. Those of you overseas, 30 meters. Signal attenuates. It means the signal drops or reduces. That's what attenuation means here over long range. But you can also have repeaters, but it's not the recommended stuff. Same thing with when we're looking at Ethernet cables. They have a limited range, but you can also extend it. Again, it's not best practice. Concrete wall metals can interfere with the signal. Other networks, radio sources such as cordless phone can interfere with it. What one security practice is about that you should always make sure you can reduce the range of your Wi-Fi signal so that somebody outside doesn't use your Wi-Fi. Of course, you reduce the range. You know, where if you're upstairs, maybe you don't get the service because the walls are interfering, or maybe you want to be able to look at, use your Wi-Fi while you're in your car or in your garage. So you got to think about that in terms of reducing the antenna or the signal strength. Here, floor wired cabling and network wall ports. You should be able to, you're used to this. Whenever you see this, is an enterprise switch you can see right there. Multiple switches with thousands of ports there. You would not be seeing this at home, but it's more for enterprise system, which means enterprise in IT means workplace. All right, so wireless network, just talking about the same thing. Enterprise network, same thing as wireless, but you have more capability. But on wireless, you can do your subnetting. All right, let's see here. So one of the labs is going to be your network settings. So we're going to talk before we get to secure browsing. Let's stop here because I don't want somebody to get lost with their questions. All right, any question on networking?
What was that you just said?
Yeah? What I just said?
I was just kidding. I was just kidding.
So networking, you have to try. You don't have to be a network engineer, but you need an understanding of networking for almost anything. So even those of us that do with like IT governance or cybersecurity, I need to understand networking principle. So I'm running a cable from one computer to another, or from the wall to, I need to know what I'm doing. Or am I using Wi-Fi? It helps you understand. Even if you're going to just be a business analyst and you're just taking this class, just have a working knowledge about what networking means.
Okay.
It takes several courses in networking to even get more advanced, but just first with a starting knowledge, know what a wired network is, wireless, know the names of the terminology, and be able to spot and say, hey, Alex said that blue cable is called, the thing at the end of the cable, to be more specific, is called an RJ45. If it's a telephone line, what's at the end is RJ11. And then the cable that sticks to that connector point, it has different, you hear the word Cat 5, Cat 6, Cat 7. That's just the grade of the cable itself. And then just understand what I need to do if I'm at home to secure my network or secure my network for my clients. You know you should avoid WEP, right? And that I want encryption so that if somebody's trying to sniff in, they cannot look at the data if they see the data, right? And then devices, just, you don't need to know the OSI module unless you're going to go further, or even the TCP/IP model. Just know that every time you communicate from your desktop or your laptop, you request something from Facebook, you request something on Instagram. The thing is going through a process. It's going through 7 layers. I'm doing the OSI. On the top, I request my session. That's the application layer. I need to have the information presented somehow. I need to have a session, you know, like a class session that we're doing now. Think about it like that, right? That's your login session at that time. And then that information that I'm requesting, which is a web page, got to go to the transport layer. And then how is it going to get to where it's going? It's going to go to the network layer, which I'm going to need to use a router. And then go all the way down to maybe the data link layer level, and then down to the computer. If you remember that computer doesn't understand Facebook.com. All those things have to be translated to numbers and then eventually to zeros and one bits.
Binary.
So that the computer can understand it, yeah. And then once it's ready, it gives you the page, it goes by the same reverse process to present the information to you. That's the whole concept about networking. Of course, a network engineer will need to know about doing subnetting, doing things that are called like spanning tree, but for purpose of this class, I just want you to understand networking devices. I know that I can get on the network either with a phone line, which is a modem, which means I'm looking at an RJ11 connector, the telephone line, or I can use fiber optics. I can use my cable, meaning I'm using the cable copper, or I can use my, I can use satellite if I'm in a remote area. I'll use my normal RJ45, you know, and you know that. All right? Good. So, Destiny? Okay. You have a question? All right, so let's go back and continue. I'm going to mute everybody again and go back and continue. All right, so we're now about secure browsing. We are 45 minutes into the class. So this portion is just telling you really that you should be aware of the risk when you use public network. I had a guy that went to the airport and created a hotspot on his phone, called it like, say, Abuja Airport, free Wi-Fi Abuja Airport. It's amazing how many people now try to get onto his Wi-Fi, and he can use it to steal your information, right? On how do you secure your privacy while you're browsing the internet and configuration parameters. So here, using Open just tells you many telephone companies obviously have open access points. If you have Xfinity, you can use it all somewhere else, but you need to have that SSL connection. If you're in the library, be careful about using the Wi-Fi in the library and what you do in the library. So these are malware threats. It's not a class on cybersecurity, but just know the types of malware: viruses, worms, Trojan horse, adware, spyware. Distinction: Worms don't need any help to propagate. Virus needs your assistance to go from one computer to the other computer. An example like coronavirus, you have to get it from somebody, right? So in the computer world, a virus like WannaCry virus, different viruses that have happened in computers. There's one that was going on a few weeks ago. Somebody has to do something for it to be on your system. So a Trojan horse is from the Greek mythology. If you remember when there was a war between Achilles and Helen to get Helen of Troy or whatever, right? So they couldn't penetrate, so they now sent a gift, a horse as a gift, but inside the horse were soldiers. So the word Trojan horse just means something that looks good, you click it, and it has bad intention. Somebody sends you, oh, you've won $1 million, or you won $10 in Amazon gift card. Click this to claim it. You click it, and then the virus goes into your system. Adware just means what it is. It's just a malware that is just selling you stuff. And a spyware, you got to be careful. It could be a keylogger. It's just stealing information from your system. The cure is to use an up-to-date browser version, which means don't use Windows 7 or before. Use Windows 10 and make sure you have the patches when they are released. If you subscribe to what's called CERT, US government, or just general cybersecurity publications, every single day they are discovering vulnerabilities or weaknesses in systems. And then the people who make the system, the manufacturers, like Windows as an example, will not issue patches, which is, think about it as your pants or your clothes is torn, I give you a patch to fix your clothes. That's all that means in IT. All right, so it says malware will spread with criminal intent, trying to remain hidden. Pop-up windows, if you ever get on, you see pop-up, or new browser toolbars, or if they change your home screen, you got malware. If you redirected, you got malware. Or banner ads, or something tell you, oh, I'm going to give you fake antivirus. Those are examples telling you that you got something wrong with your system. All right, so this is just about browser versions. Just make sure that it's you pick whichever one you want to do. I just prefer to use Chrome, and you can decide how you want to configure it. You may you may want to use more than one browser, maybe Edge. Scripting add-ons, Flash, Java. Be careful about enabling all this. We talked about scripting yesterday, but sometimes certain things require Java enabled to run. So you got to have to decide: do I really need it or I don't need it to continue? So client-side scripting, which I mean, if I have a server, if I have a client-server network, I want to disable it. So you can just go on there and say, I don't want to be able to have scripting on my client side or on the network side, which would be the server side, right? But again, it says most websites depend heavily on client side scripting. So it says some browsers will not enable you to disable that. All right, talks about, you don't need to worry about this part for now. Digitally signed code is more likely to be trustworthy. I said it already before. When you try to install something, your system will ask you, do you trust this if it's not signed? If it's signed, Microsoft automatically allow you to install it. Cookies. All right, so cookies basically is just a text file that just stores what you've been doing. You got on the system today. It's meant to make your life easier. Most website now today, because of privacy concern, when you log on, it will tell you that they use cookies to make your experience better. So it's like metadata, which is just data about data. It stores PII information too. It could be your credit card payment and all that. First party cookie, third party cookie, don't worry about distinction. What I want you to know on here is that although cookies cannot install malware on your computer, malware can read your cookies. So if you have credit card information stored on your computer as cookies and stuff, even though your cookie is not introducing malware, your computer is affected, that malware could read your cookies and of course steal your information, right? So you use cookies to track your browsing history. You can decide not to enable it, but most of the sites today want you to accept them. Let's see here. This one you don't need to worry about this part. Just spawning pop-up windows indicate malware infection, like that screen on here. Okay, browser settings. You can decide whether you want to accept cookies, accept third-party cookies. It tells you on there. You can block certain domain. You can block pop-ups. Most of the time when your pop-up is blocked, you will see a red sign on the upper right-hand corner of your URL. This is just autofill. So for me, on my laptop, I have autofill set up, so it makes it easier for me to fill out forms and to paste for stuff. But you might want to consider disabling it or definitely not using those kind of features in a public computer. Digital certificate, I said before, a certificate is like my own signature. When I sign a paper, I mean, on my own, it's just like me proving who I am as Alex. You know, somebody's got to vouch for me, maybe, like my DMV says my driver's license. If I present it to a police officer, I'm saying, hey, this is Alex. And they believe that that's my identity, right? So this just enables my identity and improves encryption. I don't want to get lost in the weeds here, but I need to explain asymmetric encryption, right? Briefly, please, right? Don't get lost. So in encryption, we got in cryptography, we got asymmetric and symmetric, right? The point about asymmetric is I have two keys. I have a public key and a private key. Symmetric, I have one key. When you log in onto the internet at home with Wi-Fi, you get one passcode. You have one key. That's symmetric. So all it's telling you here is that just know that with asymmetric encryption, you've got what's called PKI. Just leave it at that. That's another advanced cybersecurity topic. All you need to know here is asymmetric, two keys, symmetric, one key. If your certificate is invalid, it will tell you that. But if I see a padlock on my icon, as I said yesterday, it means it's a trusted site. Firewall. So the reason why you needed to understand those 7 layers of OSI, because I might want a firewall that works at the network layer. I want a firewall that works at the application layer. That one is called Web Application Firewall, WAF. But firewall, basically, think about this. I want to protect my house. So I put fire, I light fire in front of my house. So it's protecting my house from people penetrating my house, right? So all you do here is, it says really, it's called stateful firewall. It looks at the connection of stateless. Don't worry about that part. Just know that firewall can filter every packet that is coming into my system, and that I can have firewall on my host computer or can have firewall on my network. Configuration of firewall is a cybersecurity skill that you should learn later on, like in Security Plus or the CASP class or the CYSA Plus class, right? But just know that you can actually configure your firewall. Now, Windows 10 comes with a Windows Defender. It says only run one host or personal firewall. Sometimes when you install another antivirus, it will tell you to disable Windows Defender. So just be careful. Most people don't need to buy an extra antivirus, but I have Malwarebytes, and some people have McAfee. I'm going to just explain the term proxy here. Proxy is usually what you use to prevent maybe your client or your employees from getting to the network directly. So they go through a server to get into the network. So people use proxy to prevent people from going to sites that they don't want, and obviously to filter sites for security reasons, right? Let's see. That's all you need to know on here. All right. All right, quickly about shared storage. We got 5 minutes to finish this one up, and we'll talk about your labs in a minute. So in one of your exam questions, the question was, what method of storage will you use if you want to guarantee a high availability of storage? And that answer was network attached storage. All right, so let's see why that is important. Let's talk about the different kind of storage, how you can do it, right? So if I have a file server, I can allow people to have access to my file a couple of ways. So if I have a folder or a driver on my computer, I can decide to share with everybody here, right? So it's a drive on my computer. But the problem is, if I turn off my computer you can access that file or that folder. So that's the disadvantage of having a file server or directly attached file on my computer. So as long as my computer is on, you guys can access my files and use my whatever is on there on the folders, right? But a network attached storage is different. So if it's dedicated for file sharing, and of course I need to have an IP address, obviously, because anything on the internet tends to need to have an IP address, Internet Protocol address. So even if my computer is down, you can still get in there and use it. Same thing with a network printer here. If I have a printer and I'm sharing my printer with you, if my computer is off, you can't use my printer. But if I configure the printer as a network printer, even if my computer is off, I go wherever I go, you can still use that network printer. Yesterday, we talked about how to connect I think it was laser printers and stuff, or inkjet printers. The most common connection is USB, but you can also have Bluetooth, or you can use Wi-Fi. So the advantage to being on the same network is if you're upstairs in your house, you can print even if your printer is downstairs. All right, so I want to explain, before we used to have, what's that one we used to have, but most people are confused about what is a work group and what is a domain. Now Windows 10, you have all the software to have a work group. So I put this thing in here. This is not from CompTIA, this is from me to explain the difference between work group and domain. So with a work group, it's a peer-to-peer network. Peer-to-peer means all the devices provide their own resources to other people. There's no centralized control. Whereas with a client-server network, you've got one device. As you see in the diagram, you've got a server here that through the internet can supply information to all those three devices, the phone and the two computers. But with a peer-to-peer or work group, they're all connected like that, right? So no computer has kind of control over another computer. They have control over their own resources. So if you have any question, you can ask me in the end here a minute, right? So say in the work group, it tells you, every computer in the works, if I have 200 computers, they all have to be configured and give everybody access. Whereas if I have domain, I configure it on the server and I have user accounts on that server. So like Active Directory will be what most people might be used to with the Windows environment, right? And this UNC, just know the word Universal Naming Convention and paths. If you're going to be browsing, so normally now with Windows 10 or modern system, I can have a file called Alex is going to school with spaces. But usually to share files, it's better to not have spaces. So you have to have some kind of universal naming convention. It will be like Alex _going _ school to make sure that I can find it. Same thing with in the cloud. In the cloud environment, you don't have spacing. You must use a common universal naming convention, right? And I can have a shared folder. This might be a little beyond the scope, but I can map it to a local drive. This is more on the network situation. That's why you will see on your system, you see iDrive, but it's actually a shared folder that is mapped to that iDrive. And I will not create an iDrive on your computer. HTTP and HTTPS, just to remember that we prefer HTTPS. Your question yesterday had to do with FTPS and HTTPS. S at the end means it's secure. So always use HTTPS or FTPS to transfer files. Later on, you will need to know what the port numbers are, but for now, just know that file transfer is 2021, HTTP is 80, HTTPS is 443, just like SMTP was 25, and then I don't think we've covered the SSH yet. All right, so cloud computing. Yesterday, I gave access to you guys to my cloud drive on Google for the videos. That was a cloud hosted storage. Cloud storage as opposed to storage on my computer. If I had stored that video on my laptop, I can let you have it, but if I turn off my laptop, you won't have access to it. Whereas if it's in the cloud, if even I'm sleeping, you can get it through Google. So the beauty about cloud computing is based on what's called resource pooling, and of course, virtualization, we talked about it that day, and elasticity. So talking about cloud-based storage, you've got Apple, Google, Microsoft, Dropbox. These are what I call software as a service, by the way. And if we have a session on cloud, I will distinguish between SaaS, IaaS, and then PaaS. And you have Google OneDrive. Cloud-based provides app and collaboration features as well as basic storage. Office 365 is actually SaaS. Google Drive, Smart Sheets. We talked about this already. I can upload to Network of Peers. I host my own files segment. Now, backup, we talked about in the exam yesterday. Make sure you configure your backup and you test your backup. So the type of backup, am I going to back it up on-site or off-site? What kind of media I'm going to use, meaning what kind of storage am I using, a hard drive, SSD, optical drive, and then a point-in-time backup as opposed to scheduled backup. So here, later on, you will need to know the difference between incremental and differential backups, but now just know that you need to back up and test your backup. Am I back into the cloud? Am I back into network storage or local storage? Later in the cybersecurity class, you hear what's called a 3-1-1 rule about the best way to do backup. But for now, just know that you should use multiple methods for comprehensive backup. Backup critical data, that's what I was talking about, right? Same thing with database. And then operating system, I can back it up in case I have any problem, right? So this is a good distinction. Windows 7, which you shouldn't be using, has what's called backup and restore, and Windows 10 has file history. They do this essentially the same thing. And then you can schedule your backup. I think it's one of the labs. How do I want to recover my backup? What do I want to recover? How long does it take to complete the backup? Again, am I using offsite backup? Just configuration, and you almost want to test it. All right. All right. So on this unit, quickly on mobile devices, and then we're going to wrap up. There's a big section on the A+ exam mobile devices, but because everything is gone mobile and because of what's called BYOD, bring your own devices, people need to understand about how mobile devices work and how to configure them. So here, let's just we talked about gestures yesterday, speech recognition and hands-free. Just make sure you use a screen lock, PIN. You have a lockout policy, which means if you try to log in more than 3 times, I lock you out. And remote wiping is excellent to secure data, as we talked about yesterday, one of your questions. What that means is if my laptop is stolen or my iPhone is stolen, I want to be able to push a button and wipe off all the data. Of course, the computer must be on and on the network for me to be able to send the signal to wipe it off. We talked about the iOS for the Apple, Android for most common one. You can buy from the stores, different ones, right? And then SDK, just know what SDK is for software development kit. The same thing, airplane mode doesn't turn off the computer, it just disables network access. You must know how to configure your email. And then this is easy. Nowadays, most devices enable you to synchronize your data across multiple platforms. All right, good. So we really ran over a little by 6 minutes on the general information portion, but we did good. Any general question? Galaxy, Destiny. All right, so let me tell you, somebody sent an email. I also saw the email about your files. I don't know if Bree responded, but this is simple to find. I'm going to show you on my screen. If you're having a problem finding it, if you go to if you're on the class, Bree, did you show them already?
I did. I sent an email.
Okay, so anybody with a question on that, I don't have to repeat this. About finding the labs.
Yeah, well, I found them fine, but I was wondering what we should do with them. Like, is there any submissions? I mean, I know we should execute them and work on them, but are there any submissions for grading?
No, not for this one. Normally, we tend to do it in class, and then the students send me screenshots. So, but I expect you, this is more like an honor system. It's 20 lines. I expect you to go through them line at a time. One, I know I should get an email from somebody about a problem in one of the files. But let me see. I will know.
So there's hidden problems.
Alex, it was me who sent the email.
Yes. So, Ron, one of them, there was a problem with downloading a file, but let me see who's going to find it. Yeah, there's some hidden issues here and there that you might not be able to find. But like lab number one is setting up a computer. Some of you might not be able to do that because you already have your computer set up.
Yep.
Or you at least intuitively should read it. So Remy, you got the response from Bree about the labs, right?
Yes.
Did you find it?
Not really. I just wondered if I was going in the right place. I was going to Canvas. I did what she said. Click on Files.
Yeah.
And I got in there was nothing. I don't know. I don't understand. Maybe I'm using a phone.
When you click Files, you see Labs. I don't know whether it works on the phone. I'm not sure, but you see the files there, and then you go to Labs, and then you see divided up into Lab 1 to 10, and then Lab 11 to 20.
I'll try it again.
It's right there. No, it's not just you. Somebody else sent an email about it too. Or did you send from 2 different email addresses? I think it was 2 separate emails about it. All right. So please review the networking portion. And if you're interested in learning more about networking, I suggest you take the A+ class and the Network class that starts in May. And that one, we're going to have hands-on labs. So the software that we're using, which costs about $400, that's why that class is like $3,000. We're going to do actual physical labs every day in the class. So it takes us about, I'm doing it like almost like a boot camp, but because it's combined together, you're going to be doing 1 module a day. So, and that class is 9 to 4, or is it 9 to 5? So for that 3 weeks, you got to try and be 9 to 4 to take the class. It's an intense class. Chooks, how are you? Chooks. All right, so if everybody has no questions, that means I covered everything very well.
Yes, indeed.
Chooks, you are, I know you're saying something, but I can't hear you. It must be latest. Oh, hold on, I got a chart. Let's see if anybody benefits from that question on the chart. Okay, yeah, Gavin's saying that it's on the phone, but easier to use on a PC. So check that, okay? And Brit is do a walkthrough.
I'm fine, sir.
All right, Chooks.
Good evening, sir.
You have a question?
Okay, yeah, my question, is on the assignment.
Yes, which one?
I'm not able to download them, so I can't write on them.
You should be able to download them. When you click on it, it's downloadable. Some of them, I think all of them are Word document, not even just PDF.
I'm not able to do so, although I'm using a phone.
Yeah, no, you can't do it on a phone unless your phone has not only extra storage, but like when I download something on my, I use LG phone. So you have to have enough space, and you have to have probably like a PDF reader on there. But if you have a PDF reader on your phone?
Yes.
Yeah, these things tend to work better on tablets or on laptops and computers. Because you have to fill it in. But on the one for the other lab, you can actually type your answers in and then just copy. You copy like an email and then just type your answers in.
Okay.
But the labs, the thing about the labs is it is best that you do the labs on the computer, right? Because obviously some of the exercise you gotta have a computer, but have on one screen and then doing it on the other screen. So usually people send me a screenshot. So which leads me to this. If you're having a problem with the lab, when you get to the portion where you have a problem, if you're using Windows 10, please just click snip it and snip that picture and then email it to me. Or you can download the tool on there. Or in those days, just hit Control, print screen, save it, and then send it to me. All right?
Okay, I'll try that.
All right, guys.
I'll try that.
Any more questions?
Thank you.
So tonight, if you notice, it's just the labs, a lot of labs. But I need to send some more, one more set of questions before the finals tomorrow. All right? And then last module tomorrow. All right, guys.
What
Have a
hour
great day.
is the exam?
All right.
What you say?
Tomorrow?
Thank you.
What time is the exam, Paulo?
Yes, tomorrow. What time is the exam? And how many time is the exam?
Right now, I'm having it for 1 hour, but it's after class tomorrow. You have until 11:59 tomorrow night, 11:59 p.m. US time.
Okay. Thank you very much, Alex.
All right. Okay, bye-bye.